Welcome to lesson 1.1, Patterns in Division. I'm looking at page 6 and 7 in the textbook if you wanted to follow along with me. But the focus of this lesson is learning to tell whether a number is divisible by 2, 4, 5, 8, and 10 for this lesson. And my first question is, what is divisibility? So divisibility simply refers to whether a number can be divided equally by another number. Okay? And why is this important? And it's important because it gives us a shorthand way to determine whether a number is divisible by another number without actually having to perform long division, for example. And in most cases, you'll be able to just look at a number, and by knowing the rules, you'll be able to just say, yes, that number is divisible by 2 or 4 or 5, or no, it's not divisible by 2, 4, or 5. So it's just kind of a little shortcut, and it helps speed along the process and helps develop our mental math with regards to division. So by the end of this lesson, you should be able to just look at a number, let's say, the number 4,126. And you should be able to look at that number and know whether 4,126 can be divided equally by 2, 4, 5, 8, and 10. So we're going to start with divisibility rules for 2, and this is a pretty straightforward divisibility rule, and a lot of you might actually already know the divisibility rule for 2. And basically all that means is you're able to look at a number and know whether or not it's divisible by 2. How we start looking at divisibility rules for 2 particularly is we're going to start by looking at the multiples of 2, because we know any multiple of 2 will obviously be divisible by 2. So I've put a hundreds chart up on the screen here, and I'm just going to go through and I'm going to circle all of the multiples of 2. Whoops. So I know that 2, 4, 6, 8, 10, those are all multiples of 2, and they're all divisible by 2. 12, 14, 16, 18, 20. Again, those are all multiples of 2. There's something I can multiply the number 2 by to get each of those numbers. There's nothing I can multiply 2 by to get 19, so that's not a multiple of 2. There's nothing I can multiply 2 by to get 9 or 7, so those are not multiples of 2. I'm going to keep going. 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So you should start to see some sort of pattern emerging as I'm going through and I'm circling all of these multiples of 2. And I want you to look particularly at the number in the ones spot and see if you can figure out what the rule is for divisibility by 2. So I finished with my hundreds chart. What sort of pattern do you notice about the numbers that I have circled? You should have noticed that all of the numbers are an even number. And what does that mean? That an even number just means that there is a 2, a 4, a 6, an 8, or a 0 in the ones spot, or the ones place. And so just a refresher, the ones place is this last digit here. So the divisibility rule for 2 is very simple. In order to know whether a number is divisible by 2, you just need to look at the number in the ones spot, and your number needs to be even. So if you have a 2, a 4, a 6, an 8, or a 0 in your ones spot, that means you have an even number, and that means it's divisible by 2. So let's look at a couple examples. If I give you the number 474, and I say, is this number divisible by 2? You would look at this number in the ones spot. You would say 4 is an even number. So yes, it is divisible by 2. If I gave you the number 561, again, you look at the number in the ones spot and you say, no, that's an odd number, so that is not divisible by 2. So next we're going to look at the divisibility rule for 5, and we're going to follow a similar process that we did with divisibility by 2 to help us figure out the rule. Okay, so I've put another hundreds chart on the screen, and I'm going to start in the same way by going and circling the multiples of 5. And hopefully by circling all of our multiples of 5 and giving us this visual, that you can see the pattern emerging that will give us the rule for knowing whether or not a number is divisible by 5. So a multiple, so I'm circling the multiples here. So what is a multiple? So a multiple is just a number that can be divided by 5 in this case, and the answer will be a integer or a number and without a remainder. Okay, so all of these are multiples of 5 because I can divide all of these numbers by 5 equally, and there won't be a decimal or a remainder at the end. 63 is not a multiple of 5 because there's nothing, I can't divide 63 divided by 5. It would give me a decimal answer. So only the numbers I've circled are multiples of 5 that would give me a whole number answer. So looking at the numbers that I've circled, the multiples of 5, can you see the pattern or the rule for divisibility by 5? Or just what sort of patterns do you notice with what I've circled? So it's not an even number like it was with 2, because I see 5, 15, 25, those are odd numbers, whereas 10, 20, 30, 40, those are even numbers, so it's not that. But what you should notice is that all of the multiples of 5, they either have a 5 or a 0 in the ones place, right? So the number 5, 15, 25, 35, so looking at this row, all of those numbers have a 5 in the ones place. Looking at these numbers, all of those numbers have a 0 in the ones place. So our divisibility rule for 5 is that there either needs to be a 5 or a 0 in the ones place of the number. So let's do a couple examples. So if I give you the number 1,223, to know just by looking, I look at the number in my ones place, and that's a 3. So it's not a 5 or a 0, so that would not be divisible by 5. If I give you the number 47,295, again, none of the other numbers matter. I only have to look at that number in the ones spot. And the number's a 5, so therefore it is divisible by 5. If I have the number, I don't know, 1,726,910, again, none of the other numbers matter except for that number in the ones spot. It is a 0, and we know that if it's a 5 or a 0, it is divisible by 5, so therefore that would be divisible by 5. So next we're going to look at divisibility by 10, and I'm not going to put the hundreds chart up this time, but again we're going to follow the same sort of process that we've done with the last two. And it's very similar to divisibility by 5, right? Because we know that 10 is a multiple of 5, so there will be some sort of relationship or some sort of similarity between the two. So my first step is to think about the multiples of 10, and then once we see the multiples of 10, we're going to look for that pattern again. So my multiples of 10, and again, I'm not going to use a hundreds chart for this one, I'm just going to write them down. So 10, 20, 30, 40. So these are all numbers I can divide by 10, and it will give me a whole number as the answer. 60, 70, 80, 90, 100, 110, and so on. The pattern will obviously continue, so we'll stop there. So looking at the multiples of 10 that I've written down, what sort of pattern do you see emerging? Every number, every multiple of 10 has a 0 in the ones column. So that's our divisibility rule for 10. A number is only divisible by 10 if there is a 0 in the ones column, or in the ones place. And that's where we see that relationship with 5, right? Because we know that one of the divisibility rules for 5 is that it is divisible by 5 if there's a 0 in the ones column as well. Same divisibility rule for 10. So let's do a couple examples. 37,321. Okay? We have to look at that number in the ones spot. It's a 1. Okay? We know our divisibility rule for 10 has to have a 0 in the ones spot, so that would not be divisible by 10. If I look at the number 4,360, I look at my number in the ones spot, it's a 0, and I know a number is divisible by 10 if there's a 0 in the ones column, so that would be divisible by 10. So the divisibility rules for 4 is slightly different than 2, 5, and 10 than what we've done before. So what I've started off with is I've put a hundreds chart on the screen, and I've gone through the hundreds chart, and I've circled all of the different multiples of 4. But as we can see, there is some patterns we might notice. All of the numbers are even, but there's not necessarily one pattern that is true, right? We couldn't say that if a number ends in a 2 that it's divisible by 4, because only some of those numbers are divisible by 4, not all of them. Or if it ends with an even number, because there are even numbers in there that are not divisible by 4. So we can't just look at the multiples of 4 and determine a pattern. What we have to do instead for divisibility rule by 4 is look at the whole number that's given. And what I do want to point out about this hundreds chart is that the number 100 is divisible by 4, right? So 100 divided by 4 equals 25. So therefore, any multiple of 100 will be divisible by 4. So 200 divided by 4 is 50. 300 divided by 4, 75. 400 divided by 4 is 100. And so on and so on. So the important thing to note from this hundreds chart is that any multiple of 100 will be divisible by 4. Any multiple of 1,000 will be divisible by 4. Okay? So when we're looking at the divisibility rules for 4, because we know that any multiple of 100 will be divisible by 4, we only have to look at the last 2 digits. And if the last 2 digits of the number are divisible by 4, then that would mean the whole number is divisible by 4. So let's look at an example to kind of clear up what I just said. So if I have the number 232, and I say, is this number divisible by 4? We already know that the 200 part of this number is divisible by 4 because we know any multiple of 100 is divisible by 4. So in order to determine the divisibility, we have to look at the last 2 numbers, so the number in the ones place and the number in the tens place. And if that number combined is divisible by 4, then the whole number will be divisible by 4. So we already know that the 2 in 232 is divisible by 4. So I'm looking at my 32. And I know that 32 divided by 8 is 4. So therefore, 32 is divisible by 4. So I know that 232 is divisible by 4. If I look at the number 417, I know that my 400 part is divisible by 4 already. We looked at that up here. So I have to look at my last 2 digits, which is 17. And then I say, is 17 divisible by 4? And I say, no, it's not. So the number 417 is not divisible by 4. Let's do one more. What if I give you the number 1,352? I know that 1,000 is divisible by 4. I know that my 300 is divisible by 4. Because any multiple of the 100 or of the 300 is divisible by 4. Sorry, the 1,000 or the 300. So I have to look at only my last 2 digits. 52. And is 52 divisible by 4? Yes, it is. So therefore the whole number is divisible by 4. So the rule for determining the divisibility is you just look at the last 2 digits of the number, and if the last 2 digits of the number are divisible by 4, then your whole number will be divisible by 4. So the last divisibility rule for this lesson is divisibility by 8. And again, there will be some sort of similarity to the divisibility rule for 4 because there is a relationship between 4 and 8. 8 is double 4, so 4 times 2 is 8. So just keep your mind open to the fact that there will be a relationship between the divisibility rule for 4 and the divisibility rule for 8. So again, I've started off by doing the same thing. I've put up a hundreds chart and I've circled all of the numbers divisible by 8 or multiples of 8 in this hundreds chart. And I do want to point out that unlike the number 4, the number 100 is not divisible by 8. However, the number 1000 and any multiple of 1000 is divisible by 8. So 1000 divided by 8 is 125. 2000 divided by 8 is 250. 3000 divided by 8 is 375, and so on and so on. So any multiple of 1000 will be divisible by 8. However, the multiples of 100 are not divisible by 8 like they were with 4. So the divisibility rule for 8 is you have to look at the last 3 digits of the number, so the number in the 1 spot, the number in the 10 spot, and the number in the 100 spot, to figure out if the whole number is divisible by 8. Let's do an example. So if I have the number 1,192, I know that the multiples of 1,000 are divisible by 8 already. So I'm not really concerned with that number in the 1,000 spot because I know it's divisible by 8. So I'm concerned with these last 3 numbers, 192. And I have to say, okay, is 192 divisible by 8? So there might be a little bit of math involved. So is 192 divisible by 8? Is my question. Okay, now I'm going to use some mental math, and I'm going to say yes, it is, because I know that 192 divided by 8 equals 24. So because 192 is divisible by 8, that would mean that the whole number, 1,192, would be divisible by 8. So the rule for divisibility by 8, you're not concerned with a number in the 1,000 spot. You simply look at the last 3 numbers. So the number in the ones place, the number in the tens, and the number in the hundreds place, and you look at those 3 numbers, and if those 3 numbers are divisible by 8, then your whole number will be divisible by 8. So just to end off here, I've put on the screen the divisibility rules for the numbers that we've covered today, which include 2, 5, 10, 4, and 8. And I know it's been a long tutorial, but there was a lot of numbers to cover today. So just to end off, I just want you to practice what you've listened to. So I'm going to write down a number, and I want you to look at that number, and I want you to see if you can determine whether that number is divisible by 2, 5, 10, 4, and 8. So which ones is it divisible by, and which ones is it not? So the number I will leave you with is 4,750. Okay? So I want you to look at that number. Is it divisible by the numbers that we've covered today? Okay, thank you for listening.